Welcome back. Let us go through the question. Explain clearly with examples the distinction between the magnitude of displacement, which is sometimes called as distance over an interval of time, and the total length of path covered by a particle over the same interval. The magnitude of displacement is defined as the shortest distance between the initial and final position of a particle, whereas the total length of path covered by a particle is actual distance it has traveled. There is a ball thrown upwards which goes to a height h and comes down to its starting position has its magnitude of displacement to be 0, but the total length of the path covered by the ball is 2h. In the case of one-dimensional motion, the two will be equal if the particle moves only in one direction. Magnitude of average velocity over an interval of time and the average speed over the same interval. Average speed of a particle over an interval of time is defined as the total path length divided by the time interval. So in both A and B, that the second quantity is either greater than the than or equal to the first. Where is the when is the equality sign true? For simplicity, consider one-dimensional motion only. So the answer to this question would be the magnitude of average velocity over an interval of time is defined as total displacement upon the time taken, whereas the average speed over the same interval is defined as the actual distance traveled by the particle divided by the total time taken. That is, a ball thrown upwards which goes to a height h in time t and comes down to its starting position in the same time has the magnitude of average velocity 0, whereas the average speed of the ball is h by t. In the case of one-dimensional motion, the two will be equal if the particle moves only in one direction. See you in the next one.